Okay, we're going to do Unit 5B, and this is the first section. Now this whole unit is all about finding solutions and how there's lots of different ways to find solutions, and we're still dealing with parabolas, so that's why it's the second part of Chapter 5. So 5A was how to draw and how to factor, and now we're going to talk about how to find solutions when we're dealing with parabolas. Now, solutions have a lot of different names. They can be zeros, sometimes we call, and sometimes we call them roots. All of this means, all of these answer the question, where does the parabola cross the x-axis? So where does the parabola cross the x-axis? Okay? Now, there's three possibilities when you come to solutions. The first possibility is that it doesn't cross the x-axis and it looks like this. Or it could be downward facing but doesn't cross. It could be concave down, but it doesn't cross the x-axis. This means there are no real solutions. There are solutions. They're imaginary. And you don't get to learn about that till Algebra 2. So I know you're disappointed. I guess you could ask an Algebra 2 student to talk to you about imaginary numbers. But at this point in your algebra career, you're going to just say no real solutions. Don't say no solutions. There are solutions. We just haven't learned about them yet. Okay? The other possibility, we sometimes call this a double root, is where it kind of sits on the x-axis, so it's not really crossing the x-axis. It hits the x-axis and goes back up. In that case, we have one real solution. Again, you see that word real coming up again. There's one real solution if it looks like that. If it looks like this, where it crosses the x-axis twice, then we have two real solutions. Okay? So these are the possibilities of what could happen. Now, graphing is not the most precise way of finding a solution, but it is a way to find a solution. So we're going to do three examples, and the first one I'm going to show you all the steps, and then the last two I'm just going to move quickly through. If you don't know how to graph a parabola, you're already in trouble. So you need to go back and you need to practice how to graph a parabola. Math builds on itself. So just because that test is over doesn't mean that concept is done. If you can't graph a parabola, you're going to have a really rough time with this section. So go back and relearn it. And you can talk to me, you can talk to your teacher, you can talk to Miss Sally, Miss B, anybody to help you relearn this. Okay? So let's look at this equation. I'm going to use f of x, which is the same as y equals, or you could put 0 equals 2x squared minus 12x minus 3. Okay? Remember, when you're graphing a parabola, the most important thing is that you know the vertex. If you can't find the vertex, you can't graph a parabola because you aren't going to know where to start. This is in standard form. This should remind you that you're going to have to use x equals negative b over 2a. So let's find our a, b, and c. A is 2, b is negative 12, and c is negative 3. So it's going to be x equals negative b, which is negative 12, over 2 times a, which is 2. Notice I use parentheses. That's very deliberate. If you don't use parentheses, it's very easy to mix up your negatives. So make sure you use your parentheses. Sorry about that, guys. Okay, and so then we get 12, positive 12 over 4. And so then we get 3 as our y, or the x value of our vertex, and x equals 3 is our axis of symmetry. So remember, we're trying to find the vertex to get started here. We only have one piece of the vertex, which is 3. We need the second piece, so we're going to have to substitute this back in. F of 3 is what we're looking for. Remember doing this. 2, and again, I'm going to use parentheses where my x's were. So I'm using this equation, and I'm going to put in 3 for my x's. So 3, 3. Remember, when solving a function, we leave the left side alone, or the side with the f of x on it. Whoops, f of 3 is what we're looking for, because that's what we're looking for. That's our y value. And this is going to be 2 times 9 minus 36 minus 3. And when you finish this, you're going to get f of 3 equals 21. So our vertex is 321. Okay, now we can start our graphing. Remember, we need a table of values. We need 5 values in that table. We have to know where to start by putting the vertex in the middle. And the vertex was 321. Always put your vertex in the middle. I saw a lot of you on the test trying to put 0 in the middle, and you were getting wonky looking parabolas because you didn't know what you were looking at. The whole point of putting the vertex in the middle of the table is so that we're looking at the correct part of the vertex, the curve, and not like the upper right-hand corner of it that looks like a line. Okay, then from there, we just fill in our 4, 5, or 2, 1. And then I use my graphing calculator to figure out what comes next. Oh, you know what? It's supposed to be negative 21. I messed up. I hope some of you noticed that. I noticed it when I just looked down. So that would have made this problem look really weird. So that's why you want to be really careful. I was going a little too fast. And then when I put in the graphing calculator, we find out 2 is negative 19, 4 is negative 19, and then 5 is negative 13, and so is 1. Okay, and again, I use second table on my graphing calculator. Now this is way down in the negatives, so let me make my, I don't know how to make that extra long. No, I want this to be extra long. So let's see if I can make a line. I don't know, I've never done this, so let's try. I want to extend this. No, it didn't make it straight, but that's okay. All right, so let's start with 3, negative 21. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There we go. And then negative 19, we have 2, negative 19 is here. And then our next one is 5, 13. I'm going to have to count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, now I'm going to connect it. I'm going to do my very best to make this look correct. But because I'm freehanding it, like I said, graphing is not the most precise way of finding your solutions, but we're going to do the best we can. Whoa, I don't want to do that. Let me take this off. Now you want to give me straight lines. I needed a straight line a second ago and you didn't want to do that. Okay, well, that's pretty crappy, but I did my best. Okay, here's where our solutions come from. Here and here. If you copy my answers from the homework, I know you're not doing this on your own. Your answers should match your graph. So they're going to be different because of the way you draw compared to where I draw. So it looks like for me, that dot is too big. So let me take, oh, that's not what I wanted. Did I just take that? No, it's not going to let me. So I need, it looks like negative 1.2 is the first place it crosses. And the other one looks like 1, 2, 3, 4, 5, 6, 7, 8.1. Now that's not exact at all. In fact, I put this in my calculator to figure out what it was, and it was negative 0.2 and positive 6.24. But what I want you to practice right now is picking it off a graph. So if your graph is a little off, your solutions are going to be a little off for now. And what I'm going to check, and what Mr. McGrath is going to check with these, I'm going to look at your graph and look at your solutions, and they should match. Otherwise, I know you just copied my answers from the homework. All right, example 2 is already in vertex form. I know this is going to face down because my A, which is negative 2, is negative. Okay? Now remember, because this is in vertex form, we don't need to do A, B, or C. What we have to remember, though, is that the X value switches signs. So it's not negative 3, it's positive 3 and 4. If you put negative 3 and 4, when you look at when you look at your table, you're not going to find that on there. So you know you made a mistake when that happens. Okay? I'm going to look at my table of values on my graphing calculator, and if you don't know how to do that, go back and watch the graphing calculator video. 3, 4 goes in the middle because that's my vertex, so that's where we want to build our graph from, is from our vertex. And so then I build up and down from there. 4, 5, and 2, 1. And then I look at my graphing calculator, or I do substitution, and I figure out the y values. If you don't know what I'm talking about, you need to go back and practice graphing parabolas. And you'll find that in the other module, in module 5A. Okay, so let's graph this one. I don't have to make this. Oh, what happened? I tried to make this nice and it didn't work. Let me try again. Okay, this one doesn't need to be quite as big because we're not dealing with huge numbers anymore. So 3, 4 is my first one. 1, 2, 3, 1, 2, 3, 4. There's my vertex. And then it goes 2, 2, and 4, 2, and 1, negative 4. 1, 2, 3, 4, and 5, negative 4. And I'm going to do my best to make a parabola. Oops. Okay, well, I missed that point a little bit. So then I'm going to put my dots. They're green, where my solutions are. And my solution looks like, on my graph, like 1.5 and 1, 2, 3, 4, 5.1. Is that exact? Nope. I know what the real answers are because I went and figured it out. But that's what I'm looking for. I'm looking for your graph and your solutions to match. Let's do one more. And this one is, let's do y equals this time. It means the same thing. Y equals 5x squared minus 10x plus 7. It's in standard form, so that means we have to come figure out the vertex. It's not just staring us in the face. A is 5, B is negative 10, and C is 7. So we're going to put it into this equation, negative b over 2a. And so it's going to be negative 10 over 2 times a in this case is 5. So when you figure that out, you're going to get 1. X equals 1. And then you have to plug back in over here to find out, oops, we don't want an x in there, we want a blank, what y equals. Okay, so then I'm going to go put 1 back into this equation to figure out what y equals. And in this case, it's going to be y equals 2. Okay, now I'm going to go to my table, so this should look familiar. Nothing really brand new here. You should be graphing just like you always have been. We're just looking for something different on our graph this time. So 1 and 2 goes in the middle. That's my vertex. And I count up and down from there. 2, 3, 0, negative 1. And again, I used my graphing calculator for this. It's up to you. 7, and then 22. Now 22 is probably not going to fit on my graph, but I'm at least going to have an idea how that this is goes up fast. Okay, so let me make our x, y. And again, we're looking for the solutions. Where does it cross the x-axis? Okay, so let's start with 1, 2. And then it goes to 2, 7. And 0, 7. So you can see this is pretty thin, because then we go all the way up to 22. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 22. So this is pretty narrow. Again, it's supposed to look like a U. It's not supposed to be pointy. But this one is not crossing the x-axis at all. So your answer to this is no real, and you need to write no real solution. Okay? All right, so go back and review it if you need to, or talk to your teacher. And then in order to find the solutions, you have to graph the parabola.